In this video, we're going to look at some common material you can make from the solids we've been talking about in the previous videos. And that would be your ceramics, cement, and glass. So let's talk about ceramics first. So these are inorganic, non-metallic solids. Inorganic means no carbon is in there. You make these with powders, mix it with water, shape it, heat it, and you can get a variety of different goods from this. Bricks, tiles, pottery, dishware, insulating elements, etc. Now, many of these ceramics are aluminosilicates. That's minerals which you have silicon atoms that are actually replaced from aluminum. So we talked about silicates in our last video, so just imagine that every once in a while that silicon is replaced with an aluminum atom. And weathering these aluminosilicates is how we get clay. And if you ever use clay, you can heat it and you make it into a ceramic. Now, another type of ceramic is called an oxide ceramic, and that's where you have oxygen in your ceramic. So Al2O3 and MgO are common oxide ceramics. And these compounds have very high melting temperatures. So aluminum oxide here has a melting temperature of 2072 C, compared to just straight up aluminum metal, which melts at 660 C. So these oxide ceramics are usually used in high temperature applications. So think of furnaces, cutting tools that generate a lot of heat, crucibles. We've used crucibles in the lab. That's what we use to hold things while we put a flame underneath it. Different heating elements, and in fireproofing. Now, the problem with ceramics is that they're usually brittle. So when people first discovered these oxide ceramics and learned how to use them and make them, people wanted to make an engine out of ceramic because it's very heat resistant. The only problem is that these engines would break very easily because ceramics are brittle, and if temperature changes too fast, these will break. That's why in the lab we say if you heat a crucible, do not pour water directly into it until it's cooled down a little bit, or you will break the crucible. Now, the next type of compound we're going to talk about is cement. And cement's been known for a long time. The Romans knew what it was. They used a different type of cement than we use today. They used lime, volcanic ash, and clay to make their cement. Today, the cement that is used is called Portland cement. And it's a mixture of limestone, silica, some alumina, iron oxide, and gypsum. This mixture, when it is exposed to water, a lot of complex chemistry happens, but at the end of the day, you get a substance that resembles rock. And this forms the silicon-oxygen silica bridges that will produce fiber structures and make this extremely strong. Now, Portland cement can be combined with sand and pebbles, and that's how you get your concrete. So concrete is just cement with rocks and sand in it, basically. Now, the next compound is glass. You get glass by taking silica and melting it, so above 1500 C, and then cool it very quickly so it does not reform into quartz. So remember in the last video we said that silicas will form quartz. Well, you can melt it and cool it extremely fast and you'll get glass. And this is because the silicon and oxygen atoms don't have time to form this nice network structure. Rather, it's random, ordered, amorphous structure. And Romans, again, they knew how to make glass, so they were the first one to successfully develop glass making as a skill. Other cultures had glass, but they wasn't as developed as the Romans. Now, for glass, you can add sodium carbonate to the silica, and this will lower the melting point, making it easier to create glass. Now, when this SiO2 is made into glass, the result, you call that vitreous silica or fused silica. And this type of glass, or vitreous silica, is hard, very heat resistant, doesn't really expand with heat, and it's transparent to visible in UV light. But that's not usually the glass we see every day. Most glass we use and see is called soda lime glass or window glass, where you have 70% silica, Then you have some sodium oxide and calcium oxide. That's usually the glass that you're going to be seeing in your day-to-day life. Now, the problem with this soda lime glass is that it will break under thermal shock. So you heat it up, cool it down too fast, your glass is going to shatter. So the way to get around that is to add boric oxide instead of calcium oxide, and you create borosilicate glass, or you know it as Pyrex. So Pyrex doesn't really expand when heated, so it can absorb thermal shock way better than your soda lime glass. Now, another type of glass we have is called crystal glass or leaded glass, and this happens when you take lead and you mix it with the silica oxide. And you get a very brilliant appearance because it's going to bend more light. And these are the glasses where you hit it on the side and you get that ringing sound. So if you ever been to a wedding and people are hitting their glass and you're getting that ring sound, they're usually using leaded glass. Now, as you can see, leaded glass has lead in it, which is not great if you're using it to drink. So the worry about lead has led to alternative types of crystal glass, which is lead-free crystal, but has the same properties as your classical leaded glass. And that is it for this video. I will see you in the next one.